Good morning. Thank you all very much for coming today. My name is Jay Roxe. I'm a development lead on .NET frameworks, and the title of today's talk is Handling the Basics, Getting the Most Out of the Framework. I'm sure most of you took a Western civilization class in high school where you studied everything from the Athenian city-state through the Second World War in a single semester. You can think of this morning's talk as being the equivalent type of survey course for the base class library, but there's no test at the end. The purpose of today's talk is to give you a feeling for the different functionality that we built into the base class library, what some of the performance concerns are that you'll need to be aware of when writing your own classes, what the extensibility points are that we use to allow you to create your own classes that fit into this model, and I'm going to motivate this all with a small demo application. I mentioned that this was a survey course, and the agenda certainly gives some feeling for that. We'll start with the base data types, and then work our way through strings, regular expressions, globalization, collections, I/O, serialization, and cryptography. If we could switch to the demo, please. What I've written here is the address book for the Acme Corporation. Now, Acme is a fairly small corporation that just has a few employees, and this demo is designed and written entirely using the things that we'll be talking about during the talk today. We'll be using a strongly typed list to store the information on the employees in the Acme Corporation. We'll be using string parsing and formatting to display the information. We'll be using serialization and streams to save that information out to some type of persisted store. I created a few employees for the Acme Corporation this morning, so let me just go ahead and load those up. That's used serialization and a stream to pull that information in. As I go through my talk today, I'll switch from the slides over to the code that was used to write this demo, and we can take a look at how it's actually implemented. If I go through the process of adding an employee, and who better for the Acme Corporation than Wile E. Coyote? I'll give Wiley a salary of $50,000 a year, and we'll use the parsing functionality built into the floating point classes to parse that number. And let's say that Wiley was just hired today. We'll use information built into the datetime class to parse that date into the internal representation. If I take a look at all of the employees of the Acme Corporation, you'll see there are 4 of them. Wiley was just hired today, Sam Smith, who was hired today, and 2 others. I've used string formatting and a text widget to display this information. As you can see, the salaries and dates are currently formatted using the US English Standard. If I wanted to format this for French, I can simply change the current culture, and you'll notice that all of the currencies are now formatted for French, and the month and day has switched on the date. If I switched over to Japanese, you'll notice that the currencies change again, and that the month, day, year order on my dates has changed as well. Now, if I were writing an industrial strength address book for the Acme Corporation, I'd certainly use it writing some flashier than a text widget, perhaps some type of data grid, and I'd use a database as my back-end store. However, this is designed to serve as a demo of things which we'll be talking about here today. You could go back to the slides, please. The first thing that we're going to talk about are the base data types. And if you'll notice underneath base data types, I've put the word system. As we switch from one topic to the other, I'll go back to the agenda and show you the namespace in which the classes that we're going to be talking about are found. In the case of the base data types, they're found in the system namespace. The base data types, as I'm talking about them in the talk, are the primitive and common types that we all use in our everyday programming problems. They're bytes, it's integers, it's decimals, it's date times. In the .NET frameworks, these types have three main purposes. They serve as the object form of the primitives, they're used for formatting and parsing, and they're used for conversion to other types. When you create an integer, let's say the number 5, it just gets created as 4 bytes on the stack, as you'd expect. However, if I need to put that integer into a generic function that consumes an object, I need a way to box that information on the stack onto an object that lives on the heap. The base data types provide the object wrapper that serves that functionality. In many languages, including C# and VB, the boxing operation, which is the conversion from a primitive type on the stack to an object on the heap, the unboxing operation, which is the reverse, is handled automatically. A very common thing to want to do with some of these base data types is convert them to and from a string. Certainly if you're reading your input or displaying text out to your users, you're going to need to do this. The .NET framework provides two different patterns for doing this. The first, and simplest, is the toString and FromString functionality. ToString is available on all of the base data types and simply converts the number, let's say that 5 we were mentioning earlier, to a simple string. FromString will read that simple string and convert it to that primitive type. As you noticed from the demo when I switched from French to Japanese to English, there are differences in how currencies and numbers are formatted in different places. In the US, the period is used as the decimal separator, and a comma is used as the thousand separator. If I went to Europe, the comma is used as the decimal separator, and a period or space used as the thousand separator. The toString and FromString functionalities don't pay any attention to these changes. They always use the period for the decimal separator and the comma for the thousand separator. However, we've provided format and parse functionality on all of the base data types that provides a much richer set conversions. For example, format can handle displaying a double precision number in various different styles, and parse will pay attention to the user's current cultural preferences. Do they use a $ or a yen sign for their currency? Last thing that I want to touch on base data types is the conversion from one type to another. Programmatically, if I'm writing this, you can think of this just being a cast, say from a double to an int. However, there are times I need to be able to do this programmatically. If I'm doing it in a late-bound fashion, or if I need to guarantee common conversion semantics across languages. The base data types provide that functionality, but the place from which I'd suggest that you access it is the convert class. Convert is available to all of the languages that use the .NET frameworks and contains a series of static methods that will do the conversion, for example, from a double integer or an integer to a string. If you went to Bill Gates' keynote yesterday, you heard him refer to XML as the new lingua franca of the web. Whether you're working in XML or HTML, string is your most important data type. And there are three things that I want to touch on the string class that .NET Frameworks provides. I'm going to cover string creation, string comparison, and string formatting. A string class in the .NET Frameworks is completely Unicode internally. String comparison is a very common operation. I want to know if these two names are the same, or these two tags that I just read off the wire contain the same information. The framework provides two types of string comparisons. The first is ordinal comparison. This is just, are these two characters exactly the same, or how would they sort if I just looked at their numeric value? For those of you that do C programming, you can think of this as being strcomp. However, there are times when I need to pay attention to cultural differences that can occur in string. For example, the German sharp S can be represented in Unicode using both a single Unicode character and two S's. Semantically, if I'm displaying these to the user, those should sort exactly the same. The compare method on the string class is globalization aware and will pay attention to these types of differences. Many of the functions that you'll find on the string class, index of, compare, to upper, to lower, are all convenience wrappers for globalization functionality. Obviously, if you're going to be working with strings, you're going to need the ability to create them. The most common way of doing this is simply to concatenate together strings that you already have. I have two code snippets on the slide, string concat A, B, and C, and A plus B plus C. These will produce the same string, ABC. In fact, the second line, A plus B plus C, will compile down to be exactly a call to string cat. Another thing to note when you're creating strings is that strings are immutable. This gets you a lot of advantages in being able to reference the same string multiple places, even on multiple different threads, and not have to worry about anybody changing the information on that string. Of course, we do provide methods such as append on string that allow you to put new information onto that string, but what you've done there is create a new string object. However, if I'm doing something like building up HTML response string or a query string, I don't necessarily have all of the information that I need up front in order to be able to call string concat. I need a way of building the string incrementally. The string builder class provides that functionality. What it does is maintain an internal data structure that's you can think of as a self-growing string, where I can append, insert, remove strings without creating any intermediate garbage. And then when I'm done, I've created the string that I need. I call the toString method on string builder, and I get back the completed string. One last thing to note here is that the transformation functions on string, to upper, to lower, trim, all return a new string object. The last thing that I want to talk about for strings is string formatting. Many of you will have used this if you format exceptions for output to your user. The string.format method in the frameworks provides the ability to control format, width, padding, and alignment. For example, there are multiple different ways in which you might want to format a double number. Do you want exponents, or do you want to print as many decimal points as you can? The format that you wish to use to format the string is controlled with either picture strings or with format codes. If you take a look at the three code snippets that I have up on the screen, the first one, string format, please order 0 widgets at 1 each, shows the simplest use of the string format method. What's going to happen here is the data in I is going to be substituted in where you see the 0, and the data in F is going to be substituted in where you see the 1. Now, I haven't specified anything in terms of how I want this information formatted, so I'm just going to get a default format for that. In the second example, I show one of the ways that you can use to specify the format that you want. For those of you that have used picture strings before in Visual Basic, this will be very familiar to you. In this case, I've said I want object 0, and after the colon, specify the format string that I want to use. In this case, I'm saying that I have 2 digits of precision, guaranteed 2 digits before the decimal point, and then an additional 2 digits before that if there's enough information. The final thing to mention about formatting is that you can also use a control code. If you look at the last code snippet, I want to format element 0, my date time, using a format code that's peculiar to date time. In the case of U, I'm just saying that I want the date time formatted in a universal sortable format. If you want to define your own class you're going to be using through string formatting, and you want to specify some rich formatting functionality for that class. The way you do that is to implement the iFormatable method. iFormatable is called whenever string.format encounters object of the appropriate type. The format string, either the U or the picture string from this example, is passed to the appropriate method on the iFormatable interface, and that object gets to control how it formats itself. We could switch over to the demo for a second. I have here all of my Acme employees, and the information on this text widget was formatted using the string format commands. If we took a look at the code for how I did this, I've written a display directory entries function that takes the collection for the employees that I wish to display and the text box in which I wish to display it. The text box only allows me to specify a single string as the argument for the text. So this is the perfect place where I want to use a string builder, incrementally build up the information on my employees. I've specified the format string that I'm going to use to format the information up here. I specify the element I want formatted, in this case 0, the name of the employee, followed by the width that I want that formatted to. So in this case, I want to format element 0, the name, with 15 characters, element 1, the address, with 20 characters, element 2, the phone number, with 15 characters, element 3 is the salary. It's 13 characters wide, but if I just went and I've stored that as a float. So if I just went and printed that, it wouldn't come across as a currency. It would just be a floating point number. So what I do is explicitly say, using the C format, that I want that formatted as a currency. My last one is my date time, is the date of hire. Element 4, it's 13 characters wide, and I want to use the short date format. Now, one thing to note here is when I switched from French to Japanese to English, the format that I got for my currencies and my date times switched as was appropriate to the culture. And this is one of the advantages of using the formatting methods. I call the string format command using the format string and an array of the appropriate arguments that I've built up. I append that to my string builder, and when I've completed all my employees and just want to set that data into the text widget, I call the toString method on my string builder and assign it to the appropriate property. If we go back to the slides, please. Next thing that I'd like to talk about are the regular expression classes, which are located in the system text regular expressions package. Regular expressions provide a very rich way of working with different types of strings. The regular expression classes, which are available in the .NET frameworks, provide both match and replace capability. So I can determine if a particular string matches an expression that I provided, which is very similar to grep, for those of you that use that utility. The functionality that's provided in the frameworks is compatible with both Perl 5 and Friday's mastering regular expression functionality. So as you can see, it's a very rich set of classes. Let's take a quick look at how I do both a match and replace operation using regular expressions. I just call the isMatch function, which is a static function on the regular expression class. I pass it the name, I pass it the string that's my argument against which I wish to do the comparison, and then the string that I wish to use for my expression. In this example, I want to see if Acme Corporation matches the expression .*e .*n. Since it does indeed match that, this function call is going to return true. The other thing that the regular expression classes support is replace functionality. Let's say I had the string A equals B, and I want to switch it so that it says B equals A. I pass A equals B as my first argument. the expression that I want to use, which in this case is dot star equals dot star, and I've grouped the two terms that I want to stay together. In this case, A will be one term, B will be the other term. And then I provide the expression that I want to use as the output. 2 equals 1 will take my second term and put it before my first term. So my output from here will be B equals A. There are 3 different ways of using regular expressions that really vary on what you're trying to do with them. The first one that I just showed you is statically. I'm just calling methods on the regex class. This is great if you want to do a couple of comparisons or you have a couple of simple replaces that need to be done. However, as you all know, it takes some processing to build up the finite state autonoma to do a regular expression match. If I'm comparing against a lot of things, I don't want to use a static method that has to build it up each time. What I can do is instantiate an instance of the regex class with the expression that I wish to use, and then call the same methods on it. Because I'm now calling an instance method, it doesn't have to build up that finite state each time, and I can get vastly improved performance. The code snippet that I've showed there is an example of creating a regex using the dot star E, dot star N, and then checking if it matches Acme Corporation. I get some advantages here if I were also checking if it matched Microsoft Corporation, Orange County Convention Center, or Peabody Hotel. I'd only get one match in that case. The third type of regular expression, and the fast way of doing the comparisons, is to use compiled. What this does is take actual finite state that we build up inside the regular expression object, convert it to IL, and then that IL is compiled to machine native code. So you're actually doing regular expression comparisons in optimized native code. This is very fast, but it takes a little bit longer to build up than creating an interpreted regular expression object. It's about twice as expensive to create one of these, but each one of the comparisons that you do is 70% faster. Because these consume a bunch more system resources than the interpreted form, my guideline for when I use them is only if I'm going to be using them as a static variable in a class and using them to do a lot of different comparisons or replace operations. The next thing that I'd like to touch on are the collections classes. Now, collections are something that we all use every day. Whether or not I'm creating a queue of work that I need to do later, hashing some information in a hash table, or using an array list just to provide growable array functionality, this is certainly something that you're going to want to use. However, I found that every time I address a new programming problem, there's a special type of collection that I need to use to solve a particular part of that problem, and that collection is particular to the problem I'm solving. So what we've defined is an interface-based model that allows you to define your own collections that fit into a general framework that we've provided. We also, of course, provide a series of the most common collections that you'll want: your stack, your queue, your array lists, your hash tables that you can use. The base of the collections hierarchy is the iCollection interface. This interface provides the ability to enumerate all of the elements in a collection, convert that collection to an array, do some checks for synchronization, and whether or not that collection is read-only. What you'll notice it doesn't provide is the ability to add or remove items from a collection. Now, since this is generally very useful functionality, this is available on the iList and the iDictionary interfaces. Both of these are derived from iCollection and additionally add the add, remove, and search capabilities that you'd expect. You can think of iList like it's an array or a growable array. It's an indexable series of values. iDictionary is a set of key value pairs where the key is associated with the value. The most common example of one of these is a hash table. As I mentioned, the frameworks also provide some of the common collections that you're going to want to use. And these are already highly optimized implementations. If we take a look at how to do some simple operations on these collections, I have an example up on the slide of using an array list just to store some string data. We have default indexers on these collections, which means I can treat my array list just like it were an array. Let's say I want to put the information, my string data, into a list that I've created at element 5. I create the array list, and then at element 5, I can add my string data. When I want to extract the information out, it's just the reverse operation. However, notice I have to cast the information that I took out from being an object, which is how it's stored in the collection itself, to the strong type that I want, in this case a string. Hash table, which is an implementation of iDictionary, works very similarly. However, instead of using an integer, the 5, as my index to the table, I've used some key, my data key, as the index and associated it with my data object. Extraction works similarly, except I have to make sure to cast the information that's taken out of my table to be an instance of data. The model that I've just described is the base collection framework that we provided, and you can certainly use that without understanding what I'm going to be describing on the next 2 slides. What I want to do here is motivate a little bit why we decided to go with an interface-based implementation. I highlighted on the previous slide that when I extracted information from collections, I had to cast it to be a string. There are a lot of advantages that I could gain if I had a strongly typed collection. It's certainly more user documenting to have a method, an add method that takes a string, than have an add method that takes an object and have the user have to know that that consumes a string. However, at the same time, I want to have the ability to treat a collection generically. Let's say I have a function someplace that formats all the items in my collection for output, and it doesn't care if they're buttons or string or some type of data object. I don't want to have to write that for each of the collections that I create. The .NET Frameworks has something called private interface implementation that allows you to define the strongly typed method, in this case the add instance that takes a button, and also define the method that's implemented on the interface. In this case, the add method that takes an object. The add method that takes a button is only visible when I've created the button list. If I then took that button list and cast it to be an instance of an iList, the add method that takes an object becomes visible. When I'm just working with add that consumes this as a parameter, this looks like simple method overloading. However, if I were working with another method that varied its return type, this becomes increasingly rich functionality because I could have a method that returned a button, such as my indexer, when I had a button list, and then when I cast that to be an iList, I could generically access that indexer and have it return me an object. Now, private method implementation is a little bit tricky, and I'd like to graphically represent what I just talked about and see if I can clear up any confusion that might exist. Let's say I have a button list and a widget list. A widget has no connection to a button. That both have add methods on them as defined by the iList interface. If I create a button list, my users can only add buttons to them. If they tried to add anything else, they'd get a compile time error. And when they get the code drop down in the IDE, they can see what they're expected to add is a button. The same thing holds true of my widget. However, if I were to then cast both button list and widget list to be an iList, all I see is the implementation of the iList methods. So I now see 2 add methods or 2 indexers that consume objects. If I could go to the demo, please. I told you earlier that what I created to store the information for my Acme employees was a strongly typed collection. I created a class which I called directory value, which has the information for each employee, their name, address, and phone number stored as a string, and then their salary as a float, and their date of hire stored as a date-time object. What I have here is my strongly typed list. You'll see it's a directory value list, but it also implements iList. And if we go down, I have my implementation for the add method. The one that I see when I first create a directory value, excuse me, just consumes a directory value and will add that into my collection. If I cast that to be an iList, it's exposed as an object. Now this provides me useful functionality in that I can treat this collection generically, just like any other collection. But it does mean that when I have users who may add something in this collection, I have to check to make sure that the only thing that they're adding is a directory value. If we could go back to the slides, please. Last thing that I want to talk about on collections is how to enumerate a collection. Now you can think of an enumerator as just being a sequential walk of a collection. It will give you back each of the elements in the collection and allow you to perform some operation on it. In the code snippet that I have up on the slide, I'm enumerating over all of the elements in my button list, all of my buttons, and just writing them out to the console. Usually printing buttons to a console isn't all that interesting, but you can envision putting something more complicated, additional processing functionality inside the body of that loop. Just like any of the other methods that we have in the collections hierarchy, you can get a strongly typed enumerator back for the collections you create. It's no longer true that you can write a web application that's just going to be used by people in the United States or even people in a more confined geographic area. Your users these days are going to come from New York, Toledo, Tokyo, Singapore, Paris, and all points in between. So it's very important that your code be globalization aware and handle resources and formatting appropriately. This is one of the base principles that we've designed into the .NET frameworks, and we've tried to make it as straightforward as possible for you to do the right thing in terms of formatting your information for output to users in various cultures. The class that you'll reference most common when setting up cultures is the culture info. This is a set of preferences based on the user's language and culture. It'll include information like how they want their numbers formatted, what is their currency symbol, how they like their dates formatted, what their preferred calendar is. And there are really two different types of culture infos that you'll see a lot. You'll see the current culture, which is used for date and number formatting and string comparison and casing. And you'll see the current UI culture, which is used for resource selection. Culture is available on a per-thread basis, which at first seems like a so what, until you consider writing a web server of some type that will be handling input from multiple cultures. Say I get a request from my user, and I graph that request, and see that this user is coming in from the Japanese locale. I can set the current culture and the current UI culture to be Japanese, and all of the formatting, the resource selection, and the parsing that happens while I'm processing that request will automatically be in Japanese. There's no further work required on the part of the developer. We split current culture and current UI culture, which I know is a difference from Win9x and WinNT for those that have programmed in those environments. We followed the lead of Windows 2000 on this, and the advantage of having them separate is that if I'm writing an application that works for a multinational corporation, I may want users to be able to see their resource strings, their menus, their text in their local language, but I want all of my dates and my currencies formatted as is on a common basis across the company. One of the big features of the globalization support provided in the .NET frameworks is that we have Unicode support on all platforms. This means that if you're programming against Win9X, your string collation comparisons, your two uppers and two lowers are going to happen correctly, and it doesn't matter which code pages are installed on the machine. The framework does this by carrying copies of all of the required Unicode tables: the sorting table, the casing table, and the character info table. All of our strings internally, the data that we store, is stored in Unicode. But if I'm transmitting information over the wire, a 16-bit Unicode format isn't necessarily what I want. That's pretty fat if I have a slow connection. The globalization classes provide what we call text encodings, which is the ability to convert from Unicode, which is what we use internally, to another format. That format might be UTF-8, it might be Shift-JIS if you're in Japan, or it might be one of the common code pages. A caveat to what I said earlier about the .NET frameworks carrying copies of all of the required Unicode tables is that we don't carry any of the code page tables. We simply use the ones that are installed along with the OS when we have to do a conversion from Unicode to an encoding. The globalization classes also provide the ability to get character type information. Is this character white space? Is it uppercase? Is it lowercase? And that's available on the char and char info classes. As part of the date time support that we have, we also have calendars, the ones that you expect, like the Gregorian calendar, and some calendars that subclass that, like the Japanese calendar that has to pay attention to era values, the Hijri calendar, the Hebrew calendar. If I could go back to the demo for a second, please. If you'll remember earlier, I had a radio button on the display that I had of all my employee data that caused the information that I was emitting to be formatted in French, Japanese, or English. I want to just show quickly here how simple it is to get that behavior. When I clicked the French button, I simply set the current culture on my current thread to be French, and then told it to redisplay the directory entries. I did no other work anywhere in this application to get the correctly formatted output for French or Japanese. If I could go back to the slides, please. Processing information in memory is great, but at some point you're going to want to do something with it, especially in this net and web-connected world. You're going to want to persist it to a file cache, or you're going to want to transmit it over the internet to either a client or a server. The .NET framework provides a streaming model that provides all the streams you'd expect: a memory stream, a file stream, a net stream, some buffering, and provides a base stream class that allows you to derive your own stream that plugs into this hierarchy. The base stream class itself only knows how to read and write bytes. It doesn't have the knowledge of any specific data type. It doesn't know about an int. It doesn't know about a double or a string. We provide readers and writers, which I'll talk about in a second, that provide this functionality. Keeping the base class for stream simple makes it very easy to create a composable streaming model where you can add buffering, a pipe stream, cryptography, or something that you dream up for your particular needs. So long as it subclasses stream, you'll be able to plug it into this model. The base stream class also provides synchronous and asynchronous support. Those of you that do a lot of network programming will know how nice it is to have asynchronous support built in. You can start a call that may take a while. Let's say you need to read 4 meg of information off the buffer, and then go do some other user processing so your users don't see a hang, and then get called back when it's done. The base stream class provide the synchronous and asynchronous support, and on the actual stream class itself, the synchronous methods are implemented in terms of the asynchronous methods, and the asynchronous methods are implemented in terms of the synchronous methods. No, we're not really into causing infinite loops. The advantage that this has is if you are deriving from stream, you only need to go implement one of those. Let's say I want to implement a simple stream class, and I just really care about the synchronous methods. I can go implement my synchronous methods. I inherit an implementation of the asynchronous methods from the stream base class, and my users don't see any difference. Of course, if I have particular performance concerns where I need the asynchronous methods to be very fast as well, I'd probably want to go override those. The most common point of contact that I think most people are going to have with streams and with I/O is using readers and writers. A reader and a writer sit on top of a stream. They consume the stream, and they know how to read and write user types. If I'm putting an int out to the wire or a string, this is what I'm going to want to use. You're not going to want to convert that int to bytes. The readers and writers have the knowledge of the stream data format as appropriate. For example, we provide a binary reader which writes a compact binary format where int just takes up 4 bytes on the wire, and a stream reader writer that outputs text. Stream reader writer has a knowledge in coding. Do I want this going out in Unicode? Is it UTF-8? Do I require a particular code page? Let's take a look at a sample of how I'd write some information out to a file. Since I'm going to be writing text, I want a stream writer, and the most straightforward way to get one of those is to go to the file class and call the createText method, passing it the name of the file that you want to create. CreateText will create a file stream to the file that I've requested, and then put a stream writer on top of that. I can then write information right out to that file. In this case, I want to write the string hello world, the number 5, and what everybody will recognize the first approximation of pi. This will all be converted to text. Since I didn't specify anything to the stream writer, it'll go out as UTF-8, and it'll just be put onto the stream. I can then close the stream writer, which closes the underlying stream, and that information is safely saved to a file. If I wanted to read it back, I could go to the file class, call the openText method, get a stream reader, and just basically do the reverse of the operations we've just seen here. I've heard a couple of different definitions of serialization while I've been walking around the conference this week. One of them is ensuring that the calls to a particular method happen in an apartment-threaded fashion, one after another. And the second is what I want to talk about here, which is taking an object graph that exists in memory someplace, flattening it out and storing it to a stream. If I said that I serialized that graph, it would mean I took that graph, all of the data in it, and all of the connections between the objects, and stored them to a stream. Deserialization would read that stream back, recreate all of those objects, restore their data, and restore the connections between them so that I have a graph with exactly the same topology. In the .NET frameworks, this is fully automatic. The only thing which I need to do as a class author is mark this object as being serializable, and we'll do the work to inspect the object's values, track the connections between the various objects, and restore that on deserialization. This support exists for all object types. If you can go create your own class this will happen for you automatically. However, there are times where the automatic serialization may not be good enough. Let's say I have a handle to a Win32 resource somewhere in my class. If I serialized that out to a file, or serialized it to a stream, sent that stream to another machine, that handle value isn't valid when I restore it. What I can do in iSerializable is take control of the serialization process on a per object basis and control what data that object sends. What that means I could do is send enough information across the wire that I can restore that handle on the other end. I haven't said anything yet about what the on-stream format is for the information that we've serialized. We have pluggable formatter architecture where you can define your own format as you see appropriate. We provide a compact binary format and a SOAP formatter as well. However, if you have particular needs that need to connect to a proprietary format, the architecture is set up in such a way that you can go define your own format, implement the iFormatter interface, and it'll plug right into our model. If we could go back to the demo, please. Very quickly, I just want to show how easy it is to save out the information using serialization streams. In this case, I'm going to save all of the employees of the Acme Corporation and all their data. And it takes me 4 lines of code. I create a stream, create a binary formatter, call serialize on that formatter, passing it the object that I wish to create, I wish to serialize, which in this case, I just want to serialize the current object, all of its member variables, all of its data, and then I close the stream. Loading it back is equally easy. I open the file, create a formatter, call the deserialize method, passing it the stream, and then I'm in VB, so I'll use the C-type keyword to do a cast to the type that I'm expecting, in this case an Acme Directory Manager. In addition to the serialization and stream code that I've just shown here, you should notice that I've used VB and C# intermixed in the same application. If we could go back to the slides, please. The last thing that I want to talk about today is cryptography. Now, cryptography is something that's becoming increasingly important in the world now that we're more connected. I certainly want my bank to store any information that it keeps on me in an encrypted fashion. If my bank is transmitting information to me, or I'm transmitting information to my bank, I could use SSL for the channel between the two partners. However, if I wanted to cache some of my financial information on my disk, or if my bank wanted to store it, that should certainly be encrypted. One of the problems with the traditional Win32 API is that it's been very rich, but very difficult for the average programmer to approach. One of the design principles of the cryptography in the .NET frameworks was to make it easy for most developers to use. And one of the major customers that we considered when doing this is the web application developer. One of the primary ways of making this easier to use was to provide a simple object model that provides an abstraction for doing the crypto operations. This not only provides a higher level of abstraction than you've traditionally seen in the Win32 crypto APIs, it also provides the ability to optionally select some defaults. For example, key and initialization vector, which are required for some ciphers, are traditionally difficult for users who generate in a strong fashion. The .NET Framework's crypto classes will randomly generate these keys and initialization vectors if you don't provide them, and you can read them out of the classes as appropriate once you've finished the encryption. The .NET Frameworks provides all of the encryption classes that you'd expect. For example, we have symmetric classes, for example, triple des, or the asymmetric public key classes, such as RSA. For those of you that do more in-depth crypto operation, you should note that the .NET Framework provides support for all of the algorithms currently supported by the Crypto API, and there's a brief list of them up on the slides. Cryptography classes are also designed with extensibility and customization in mind. For example, if you have the public key class, we've provided an RSA implementation of it. You may want to subclass the RSA implementation and change the way we've done it, or subclass the public key class and provide your own implementation of that functionality. As with any object-oriented architecture, the advantage here is that you can subclass, extend, and implement only the part of the functionality that you need to change. Let's take a look at a quick sample for how I'd encrypt some data. I've defined an encrypt class here that takes as arguments the information to encrypt, the key and initialization vector, which are used to do the encryption transform. You can think of the initialization vector as just being a seed used to start the cryptography process. The return value from this class is the encrypted byte array. I create an instance of the cipher that I want to use, in this case the DES cipher, and then the symmetric stream encryptor. You can think of this as just being the object that actually does the appropriate transform using the key and the initialization vector. What we do is we connect the encryptor to a crypto memory stream using the setSync method, and the encryptor passes all of its output to the crypto memory stream, which buffers that output. After I've set up the connection between the encryptor and the crypto memory stream, I can call the write method on the encryptor to write the information I need to encrypt. I'm only writing 1 byte array worth of data, but I could set this up to write any arbitrary amount of data that I wanted. When I'm done, I close the stream, and then I just return the method from that I've stored in the crypto memory stream. This concludes our magical mystery tour over the base class libraries that are provided by the .NET frameworks. We started out by taking a look at the functionality provided in the base data types, looked at the creation, comparison, and formatting functionality provided on strings, talked a bit about the collections that are provided, the interfaces that are provided to allow you to define your own collections, and the advantages of some strongly typed collections. Moved on to the globalization functionality provided in the frameworks, and then on through regular expressions, input-output, serialization, and cryptography. Thank you very much for all of your attention. Are there any questions?
Do you support the use of templates in your collection classes?
We don't have support templates in the collection classes, but the strongly typed collections mechanism does allow you to get some of the strongly typed behavior that you'd expect from your collections if we're using templates.
Is the framework built on top of other libraries like C runtimes, or have you natively redeveloped all of the different string comparison, regular expression stuff that's been out there for years and years?
We've leveraged a lot of the functionality that already existed, but the runtime can be deployed independently.
Yeah, what kind of threading support is there in the framework classes?
There's certainly support for creating new threads, running operations on them, and we have the synchronization primitives that you'd expect to find, locks and monitor and stuff like that.
For the automatic serialization, is there any version information saved?
Yes, there is. I should mention that the information that we store during automatic serialization is versionable. we store the assembly that the type came from, which has full version information. And it's robust enough that if you, let's say, serialized a version 1 object and then only had version 2 available on your system, you can write code into version 2, know how to understand the information coming out of version 1.
Are the .NET collection classes thread safe?
What we've done for the collection classes is that they are not thread safe by default, but we do provide the ability on all of our collections classes to get a synchronized wrapper for them, which is thread safe.
Do you have any support for digital signatures?
We do have some support for digital signatures. I'm not the appropriate person to address what that support is, but I can put you in touch with the appropriate person after the talk or ask the experts tonight.
How do you format the sub-second precision on the date-time class?
On the date-time class, in addition to the format code that I showed earlier, just using U, also has the ability to provide a formatting string. So I can say what the month, day, year, and then the time, and there is a format for specifying sub-second precision. It'll be in the documentation.
Thanks.
Yep.
Does the data conversion capabilities in the system namespace have any validation for like overflow, underflow?
Yes, there is some for that.
The framework is exposing services from the operating system that traditionally would be accessed with Win32 or some other C-like API. And I'm wondering if moving forward, what happens to the future of that C-like API? I haven't noticed anything called Win64 anywhere in the conference, which is something I would have expected.
There is certainly a Win64 being developed, and you'll notice during one of the keynotes yesterday that they announced that the preliminary version of Win64 has been released. What we're really trying to focus on here is the functionality which we're providing in the .NET platform.
So for at least the next iteration of the operating system, we could expect the services to be provided both ways, through a C-like API and through this framework.
The framework and the OS are really two separate pieces. I think it's better if I address that particular question offline, if you don't mind.
Sure.
You mentioned that enumeration of a collection could be done in a type-safe manner. Can you expand on that a little bit?
Like any other thing on collections classes, there's a get enumerator method that returns the enumerator that walks the collection. I showed an example of changing the add method so that it took a button or an object. The generic enumerator will just return objects. But you can, if you're writing your own collection, you can provide an enumerator that will return, let's say, a button in the My Button list, so that when you read the element out of the enumerator, you don't have to cast it from an object to a button.
So how does that connect with the for each, when you say for each button in button list?
The for each functionality in C# is sufficiently rich that it will look for the appropriate type of enumerator when doing the for each operation.
So it would have to use reflection to do that because you don't have a way of declaring that the enumerator returns a button.
I don't know what the actual implementation is. I believe they can do it more efficiently in pile time than using reflection.
Oh. Okay, thanks.
Mm-hmm.
For the globalization abilities, is
Yes.
there any dependency on the OS, or is it totally separate? In other words, do you need the multi-lang version of the OS to get that, or is it all built into the framework somehow?
The answer is going to be depends. For something like string comparison and casing, we are independent of the OS. We have necessary tables and the necessary codes. When you're doing some of the text encoding and stuff, we still rely on the functionality that's provided by the operating system.
Okay, so does that imply you need a multi-lang OS to provide things, you know, how you're saying one thread could do this language, another thread could do another language?
I don't know exactly which operation you're trying to perform. But for the conversion that we do in the text encoding classes and the string comparisons, casings, and the formatting of numbers and currencies, we will not need a multi-line OS. Okay.
Yeah, I'm a VB developer, and I'm thinking, do I just program directly to the framework now, or do I just count on the VB developers that are doing the VB language being smart enough to do the conversion for me? I'm inclined to just start programming directly to the framework now.
Which versions are you thinking of?
Well, like a dictionary or just some of the string stuff, just any of those stuff. I mean,
I'm not familiar in detail with how VB is going to be exposed. Certainly you could access them directly through the framework, but there may also be language constructs that allow you to do the same thing. I'd have to point you and ask the experts to find somebody who's more familiar with VB on that. Thank you all very much.